Hey everyone, let's jump right into 6.2, which is on the unit circle and circular functions. So when you hear that term unit circle, it's really just a circle that has a radius of 1 unit centered at the origin. So there's a picture of it. And that circle has a lot of key features that relate to trigonometry. The reason for that is on a unit circle, when the radius is 1 unit, that just means that arc length, which is in red there, is the angle theta in radians, right? So you have theta, which is in degrees, and let's call it S, which is in radians. And then we can generate some kind of new formulas for the trig functions. They are really the definitions we had in chapter 5, like the y over r, x over r, etc. But because r is equal to 1, then you have, so that first one, sine of the angle is y over r, but r is 1. So it's really just y, right? And here, notice here they're using s instead of theta. So they're going to use, in this textbook, s when they're talking about the radian measure, and theta when they talked about the degree measure. Otherwise, those formulas now just kind of simplify because we're talking about the unit circle, okay? And so if we generate some values on that unit circle, that's the next page. Now, this is really worth printing out and putting on your refrigerator or something and memorizing these because they come up quite a bit in trig and in calculus. The way you use this, for example, let's look at this point right here, right? When I see that, I'm always thinking of the cosine value as the x value and the sine value as the y value, right? So if I had to calculate cosine pi over 3, I just look at the x value because the formula above, the cosine of the angle, is just the x coordinate. Right? So that would be 1/2. So cosine pi over 3 is 1/2. Right? Or you could say cosine 60 degrees is 1/2. Right? Pi over 3 and 60 degrees are equivalent angles, just in different measures. Okay. And if you start looking at this, you'll see lots of patterns, right? Like this angle that we just highlighted is, this point that we highlighted is the same as that point, except there's a negative on the x value, right? And you'll see the symmetry as you go down. Exact same points, just with negatives. And you'll see the same kind of symmetry here. That point and the top point there are the same, right? The middle ones are the same. And then the ones close to the x-axis are the same. Okay, so let's do some examples where we use this chart, table, whatever you want to call it, the unit circle. Right? So let's just erase all this. Okay, and we'll go to the next page where there are some examples, and we'll refer back to that unit circle. Okay, so sine 5 pi over 4. Now, our old method of chapter 5, we could draw it out, draw triangles, do the sides with 30, 60, 90 triangles and all of that, but we've kind of simplified that or combined it all into one table here. We're just going to go to where sine pi over 4 is, and I just know the sine is the y value, so that's negative root 2 over 2. Okay, so that's all I got to do. This would equal negative root 2 over 2. Okay. How about for tangent? So number 2 is tangent 2 pi over 3. So I'm going to find 2 pi over 3, right, which is here. Okay. Tangent, remember tangent is sine over cosine, or y over x. Sorry, I hope I'm not getting you seasick by all this page scrolling. Y over x. So when I'm here, I'm just thinking the y value divided by the x value, right? And then if you think about fractions, when you divide them, it's just multiplying by the reciprocal, which essentially just cancels out the 2's, right? That was negative. So this is going to be negative root 3, right? So when you're doing tangent, then you can really just ignore the denominators, right? Because they're going to cancel anyway, and just do the ratio of the top values. Root 3 over negative 1 is negative root 3, right? So that's that answer, okay? Secant is the reciprocal of cosine. So I'm just going to go to that 11 pi over 3 location, just here, right? And cosine is the x value. And I'm just going to flip that over because it's secant. So 2 over root 3. And then you should always rationalize these things. So that's 2 root 3 over 3. Okay. Negative 7 pi over 4. Okay, now we're getting into an angle that's negative. It's not going to be just something you can look up directly. You're going to have to figure out where negative 7 pi over 4 is located. You can do that graphically, or you can add 2 pi to that or something like that. But I'll show you the way I would think of that using this unit circle. So maybe just erase some of the noise here. Okay, you know that negative angles go in the clockwise direction that way, right? Okay. And I'm going to count by pi over 4s, right? Because notice where the 4 denominators are. They're always in the middle angle of each quadrant, right? So I'm going to just count how many. I'm going to count seven of those intervals in the negative direction, right? So there's 1, 2, 3, 4, 5, 6, 7. There's negative 7 pi over 4, right? So negative 7 pi over 4 and pi over 4 are coterminal. And then now once I locate the angle, then I just look it up in the point. What were we doing? Cosine, which is the x value. So that's root 2 over 2. Okay. So that counting method works pretty nicely. I can do the same thing with the next one, 13 pi over 3s, and that's a positive angle. So again, let's start over here. I'm going this way, and I'm doing pi over 3s, right? A pi over 3 is the same as 60 degrees. So if it helps just to count in intervals of 60 degrees, that works too, right? But there's the first one. I got to do 13 of them. 1, 2, 3, 4, 5, 6. There's 6 pi over 3s, which reduces to 2 pi, so that makes sense. We did one full revolution, right? Okay, so there's 6 of them. 7, 8, 9, 10, 11, 12. One more. Woo. 13. So I'm right there. Okay. So I'm just counting out 13 pi over 3s. 13 pi over 3s leads me to that point, and then we're doing cosecant. Yeah, cosecant is the reciprocal of the sine, which is the y coordinate. So I'm going to do 2 over root 3 on that one. All right. So 2 over root 3. Rationalize just like an example number 3. 2 root 3 over 3. Final answer. Let's circle all these. They're all final. Okay, cotangent negative pi over 4. All right, so cotangent negative pi over 4. So I'm going that way. That's 1 pi over 4 in this negative direction, which puts me right there. Right. So I have my angle, and cotangent is the reciprocal of tangent. Tangent is y over x. Cotangent x over y, okay? So, and I can then, again, kind of like tangent, just ignore your denominators and just do the ratio of the numerators, or it's just the same value, right? So it's going to reduce to 1, but I'm kind of thinking of it in that way, right? Root 2 divided by root 2, but that one was negative. So this is just negative 1. These last three are all quadrantal angles, which you can do it the same way. Just look up the point. So pi, where is pi? Right, there it is. Right. Pi is same as 180, and it's the sine. So that's the y coordinate, which is 0. Right. So this would be 0. Tangent 3 pi over 2. You can locate 3 pi over 2. There it is right there. Right. And the tangent is the y over the x. So the y is -1 and the x is 0. So -1 over 0, which since I get 0 in the denominator, that would be undefined. Last one, secant -3 pi. Okay, so let's go to, and well, let's find that. All right, let's see, -3 pi. Where would that be located? So negative is the clockwise direction, and we're going to count pi's, right? So there's 1, 2, back to here, 3. Right? I counted in intervals of pi or 180 degrees. So I located the point, and then I have the x is -1 and the y is 0. And this is, when you're thinking of it, it's 1 over the x, which is 1 over -1, which is -1. So secant -pi over 3 is -1. Okay, so practice with that unit circle and have fun with it. And the more you know about the unit circle, the easier calculus is going to be. Trust me. Tattoo it on your forearm if you're crazy. Okay. How about calculator? These are all have to be done with the calculator. And so notice all of these angles are in radians. So the key here is just make sure your calculator is in radians and then just type it in, right? So the only way you're going to miss these is if your calculator's in the wrong mode or you do a typo. Okay, so let's bring up the calculator. Try it out. Okay, so in mine, in this TI-84, I just go to mode, and then I go down and highlight radians and hit enter. And then I can quit. And now I'm good to go. I'm doing sine 0.4483. Okay, and there's your answer. All right, I'm in the right mode. This one, I guess we didn't say what to round to. So let's just go 3 decimal places. I think sometimes in your homework, it gets a little more extreme, like 8 or something. But I'm just going to go 3 decimal places on these answers. So there you go. That's it. The next one is on the handout. Number 11 is cosine 3.057. That's in radians. And I get a negative answer. That's okay. 0.996. Okay. Tangent -2.21. Not rocket science at this point, right? Just typing things in. 1.345. Okay, so let's clear it for the other ones. Let's look at cosecant Okay, there's no cosecant button, but I know it's the reciprocal of the sine. So I'm just going to use that fact. It's 1 over the sine of that same angle. In this case, it's 5.101109. So I'm just going to start with a 1 divided by, and then sine 5.1109. The common mistake there, I think, is to try to use that inverse. Sine of the -1 does not mean the reciprocal. It just means that's if you're given the ratio and you're trying to find the angle. Right? So don't use inverse, it's just 1 over. Right? So we're going to get negative 1.085. Good enough for now. Okay. How about secant? Okay. 1 divided by, and that's the reciprocal of the cosine. So, and then it has a negative angle. Make sure to use that negative key, not the minus sign. And then that works for this. Okay, 1.007. Awesome. Okay. And then finally, we got a cotangent. And that's the reciprocal of the tangent. So that's going to be another 1 divided by. And then tangent. And then what have we got? 8.005. Okay. All right. And then we got a negative number. Now you might be, after doing all this, you're asking yourself, what do these numbers mean? All this craziness. But if you think about what these mean, if I go back to my handout, and then we'll be done here in a minute with this idea. So here's all the answers. So what does this mean? The sine of 0.44 is 0.43. Think about these always go back to a triangle. So if you have an angle of 0.44 radians, right, then I guess I could draw it here, right? If this angle is 0.4483 radians, and you have a hypotenuse of 1, the r is 1, then the length of the opposite side, think of that as like the y, is a 0.433 units. Okay, so that's what the relationship of those numbers is. Okay, anyway, hope that is making some sense. I know it's a little crazy, a lot of information, but stick with it, keep practicing, and you'll get it. Okay, hit me up with questions if you have any. Otherwise, hope all is well. Talk to you later.